Thank you, Mr. Speaker. For Saskatchewan to prosper in the future, we need to have the energy abundance that goes with longer, healthier lives. Absolutely nothing to do with politics, as suggested by a member from Regina University, Mr. Speaker. We need to produce energy that's clean and to participate in the choices we make as communities and as a province. History has taught us that our energy needs will keep growing as we grow. SMRs provide an opportunity to generate dependable, emissions-free baseload power, and the opportunity to expand Saskatchewan's uranium market and allow our province to take advantage of new economic opportunities and increase Indigenous participation. Mr. Deputy Speaker, power production through SMR would also support our Saskatchewan growth plan by delivering on Saskatchewan's climate change strategy, prairie resilience, as well as increasing jobs associated with construction and facility operations, nuclear and non-nuclear supply chains, and research and development. We could achieve all this while reducing greenhouse gas emissions and improving resilience to the effects of climate change. Existing energy options with high atmospheric emissions are no longer desirable, and the need to reduce environmental impacts is urgent. Mr. Deputy Speaker, with new energy options emerging, we owe it to our citizens of Saskatchewan and to the future to consider our options objectively and clearly. Like all commercial nuclear reactors, small modular reactors use fission to generate thermal and electrical energy. They produce zero emissions power and are designed to be smaller than traditional reactors. SMRs are scalable and versatile nuclear reactors that typically produce 300 megawatts of electricity or less. A single 300 megawatt SMR would generate enough clean electricity each year to power 300,000 homes. They would be manufactured in factories, in modules, and then shipped to project sites for assembly to reduce cost and shorten construction schedules. The SMRs could deliver affordable, non-emitting energy for many new uses. They could not only supply power to homes, but to offices and businesses, heat for industrial processes, heat to buildings, and energy to produce clean fuels such as battery charging or hydrogen for transport. The path forward is for the advancement of SMRs and the opportunity they bring as a source of safe and reliable, zero-emissions energy to power our communities while meeting the demands of the growing economy and population. SMRs can improve our quality of life, drive economic growth and prosperity, and help our province and Canada as a whole meet its climate goals. According to the Canadian Nuclear Association, nuclear power is the most efficient power source by land area, and it's more than 15 times more efficient than renewable sources like wind and solar. SMR deployment in Saskatchewan could also be an important source of new job creation for the province, generating an estimated 100,000 jobs. It would grow private capital investment in Saskatchewan to $16 billion annually and triple the growth of the technology sector. An increase of Indigenous participation in Saskatchewan's natural resource industries could also be attained. The investment into SMR would generate $1.6 billion in GDP for the province between 2021 and 2032. As Saskatchewan has one of the largest natural reserves of high-grade uranium in the world, with around 85% of production currently being exported internationally, the use of SMRs would increase annual value of uranium sales to $2 billion. Investing in nuclear technology offers further economic opportunities for this important industrial sector. Mr. Speaker, safety is always a concern when exploring new technologies. Canada's nuclear industry has an impeccable safety track record. It's built on more than 70 years of innovation with safety and environmental protection at its core. Never in Canada has anyone been harmed or injured as a result of this industry's operations. Nuclear plants have many layers of protection, so if there is ever an issue, multiple systems keep the plant safe. SMRs are an advancement in terms of nuclear power technology and offer even further layers of protection for human safety and the environment. I was surprised to learn, Mr. Deputy Speaker, that nuclear energy has a stronger safety track record than even renewables. Data shows that renewable energy sources such as wind and solar have significantly higher energy rates as well as death rates per terawatt of energy produced. In 2021, 76% of SAS Power's electricity was generated from coal and natural gas. The use of SMRs would go a long way in decarbonization of electricity production in Saskatchewan. Mr. Deputy Speaker, there is a growing international trend towards SMRs. The United States is investing US $3.2 billion to deploy 2 SMRs by 2027. The United Kingdom is investing £210 million for SMR research and development by early 2030s. In addition, China, France, Argentina, Poland, and many other countries are at different stages of developing and deploying SMRs. We have a window of opportunity to lead as Canada has all the necessary elements: a strong international brand, flexible and performance-based regulator, world-class nuclear laboratories and demonstration sites, a mature supply chain and domestic uranium mining industry, extensive nuclear operating experience, and strong science and technology in these related areas. SMRs support long-term national energy security using Saskatchewan uranium and Canadian technologies. Ontario would see the first SMR project of 300 megawatts constructed at the Darlington nuclear site by 2028. As well, 2 fourth-generation advanced SMR would be developed in New Brunswick. Mr. Deputy Speaker, as these SMRs would be operational before we began, we could learn from their implementation. As laid out in the strategic plan, SAS Power is to finish by the evaluation and make a recommendation, followed by site selection and various regulatory steps. In 2027, the province would send to regulators an impact assessment for the first facility with the goal of it being approved by 2030. In 2030, the province would then make a decision on whether it should proceed. Construction would begin in 2031 with the first MSR operational by 2034. There, 3 more SMRs would be slated to follow in stages by 2042. A preliminary business case will be developed later this year. Part of this business case will look at how these changes would affect people's electrical bills. SMRs take about 12 years to develop, which is why we are laying the groundwork now. Nuclear energy is completely clean in terms of emissions. Both solar and wind energy are dependent on weather conditions. Nuclear energy could fill the gap with steady, reliable power. Another advantage of SMR is that they don't need a unique site design. SMRs have a small footprint, standardized parts, and a modular design that would allow scaling the size of the plant to what the local grid needs. The standardization also simplifies training and policy implementation. Mr. Deputy Speaker, SMRs can provide stable baseload clean energy to complement renewable energy sources such as wind and solar, allowing us to build a sustainable and reliable future energy supply in the province. Saskatchewan is well positioned to deploy SMRs for a safe, reliable, and affordable energy future. With that, I support the motion presented by my colleague, member for Martinsville-Vernon. Thank you, Mr. Speaker.